everybody else, what we're looking at today is Newton's laws, and just reminding ourselves about what Newton's laws are and where they apply. Okay, so by the end of the little session you should be able to clearly define what Newton's three laws are, and then we'll break down each law later on as we go through. So let's quickly talk about the three laws and what they are and what they mean. So the first law that we're going to look at, it was Newton's first law, it's the law of inertia. Okay, and inertia is basically an object's resistance to changes in mass. And if we think about inertia, it sort of makes sense and it doesn't make sense, but it's all about saying that an object will keep doing what it is doing unless acted on by an external force. Again, I said that makes sense and it doesn't make sense. It makes sense in space, okay? It makes sense in space if you think about our satellites and the fact that they keep doing what they're doing and they don't fall out of the sky. But on Earth it doesn't make as much sense because we've always got friction applying, and we're going to deal with that a little bit later on. But an object will keep doing what it's doing, and if you think about a stationary object, so for example, this, well, you use the iPad that I'm currently using, it's not going to move unless a force acts on it. But that also applies to an object that is currently moving. So if an object is moving at a constant speed of 60 kilometres an hour, let's just say a car, it should keep moving at that speed until a force acts on it. Now we know that when this happens in the real world, that's not what occurs. The car will eventually stop, or if you're on your bike and you're pedalling as hard as you want, you stop pedalling, you'll go for a bit, but you won't maintain that speed, and there's a reason for that. We'll address that later. The second law is F equals ma, and that's just saying that the size of a force is equal to the acceleration applied on the mass. So a perfect example of that, because we've been looking at gravity and acceleration due to gravity, is the fact that right now I'm standing on the ground. Okay, now if there was no force applying back upwards, I would accelerate. Let's think about that. The force that I'm applying on the ground is equal to my mass times my acceleration. So my mass is about 75 kilos times the acceleration due to gravity, about 10 metres per second. The force I'm applying on the ground is 750 newtons. Okay, and that's what that law is all about. It's just applying a quantitative value for force, mass and acceleration. I could obviously rearrange that equation to find any of those unknowns. So if I wanted to find the mass, I would divide both sides by acceleration. Okay, and that would give me the mass equals force over acceleration. So you need to be able to manipulate that equation very effectively. Some people represent this law as a triangle. I'm not a massive fan, but some people like to. Okay, the top value is F, and then M and A go on the sides. If you'd like to do that multiplication triangle, but I'm happy to leave it as F equals MA, okay, because that can be rearranged, and you need to use your rearranging skills anyway. So that's the second law. It's all just about quantifying the size of a force or identifying a relationship between force, mass and acceleration. And the third one was where I was sort of heading before. It's about equal and opposites reactions. So every force or every action has an equal and opposite reaction force. So right now, like I said, I'm applying 750 newtons down on the ground. The ground is also applying 750 newtons up on me. And I can tell you that because if that wasn't the case, if the total force between me and the ground wasn't zero, my mass would be experiencing acceleration when I'm standing very still, as you can probably tell. So therefore, I can see that that I've got an equal and opposite reaction force. You can also see that when you're firing, for example, a rifle. And if you fire a rifle with poor technique, you'll end up with a bruised shoulder. Okay, and the reason that occurs is because when you fire the bullet's applying an equal and opposite reaction force into your shoulder. Okay, so that's what recoil is all about. It's all about equal and opposite reaction force. So they're the three laws. You'll get more familiar with them, but the thing I like about it is you can always put a spin on it in your own frame of reference. You can think about these applying in your own life because they do apply, and Newton's laws of motion are really all about force. Hope that helped.